Welcome aboard. This is me, Shreyas, your physics master teacher at Vedantu. Welcome, all my lovely warriors. And I hope you guys are already aware. And in case you do not know about this, Vedantu, on our platform, we are offering you guys the promise of the year. In fact, this is something which is unheard of. We guarantee you the success. Yeah, on paper. And this is called as VIP, which is Vedantu Improvement Promise, where when you enroll into our batches and you meet certain criteria, like you attend our classes regularly and perform, in the quizzes, and you are paying attention, we guarantee that you will progress. And if you do not progress, all the fees are returned back. That's something which no coaching has done, and that's VIP. You can check out all the details which are there in the description box below. Hello Surya, hello Enthuse FC, hi Ankit, hello Tarun, Gudla, Venkata, Shreyas Kapri, welcome Pamu, welcome all the new warriors. Remember, if you are new to this channel, the only way you can mark your attendance, the only way you can make your presence felt, the only way you can make new friends is when you interact in the chat box. So keep the chat box very cool and make sure you do not misbehave, and also help each other in times of need. Welcome everyone, and this is an English channel. This is a very special exclusive channel, one of its kind in our country, and we took this initiative because there are a lot of students who are studying in English medium, be it from any part of the country, and we wanted to ensure that quality education reaches all the students out there. So that's me. I'm Shreyas, and I've been teaching for a very long time, and a lot of my students have been getting into excellent prestigious institutes like IITs and NITs with really good ranks. And over the years, I have produced lots and lots of ranks, mentored lots of students, and I really hope we continue this tradition with you guys as well. So let's get going with the session, and let me also make a very important announcement for you guys today. A lot of you guys are prepared. Very good. Yes, Ankit, I do know Abhay sir. I have interacted with him many times before the lockdown. Now, after the lockdown, we interact virtually. Shreyas Kapri says, fully prepared today. Very good, Shreyas Kapri. Shriya, very good. I hope you guys are very nice. Thank you, Satone. Well, what is this? Vedantu rank prediction test. So basically, this test will tell you where you stand in this competition, and the more people give this test, the better it is, obviously. Plus, based on our machine learning algorithms and all the software that we have, it will predict where you exactly stand right now in the competition, so that you are not underprepared or overprepared, or maybe underconfident or even overconfident. So this test is going to be on 23rd of June from 9 o'clock to 12 o'clock and 2 o'clock to 5 o'clock. There are two tests, and it's built on the JEE Advanced Pattern. Okay, so it's built on the JEE Advanced Pattern. So I would recommend all of you to give this test if you are in 12th standard, guys. All right, so that's about the test. The details are there below, and this is for all the 12th standard students and even the passing out students, and even I think for the 11th standard students. Just check it out. Oh my god, Vedantu FC, you saw me on the Vedantu ad. Which ad did you see? I'm not sure which one. Thank you, but yes, Ankit, I do know. Yep, correct. So one more thing that I would like to mention out here is that Vedantu students have been consistently outperforming the students who are not studying in Vedantu. Like if you see the JEE Advanced results last year, it's 6 to 7 times higher than the national average, where students get coached from other institutes. The ratio of the students who qualify mains, or who qualify advanced, who clear advanced, who get into IITs is always higher, be it even board examinations. It's again, you can see the difference is tremendous, and all this is because of the systems we have. And that's why I encourage you to give the rank prediction test. We also have the VIP, which is the Vedantu Improvement Promise, which guarantees you that success. We have doubt solving, we have amazing master teachers, we have the booklets which are all given to you. All this combines together to give these amazing results, much better than even offline institutes out there. And obviously we are leading in the online institutes as well, and that too at affordable prices, like you can see out here, 3,600 per month, 4,950 per month, 6,750 per month, depending on the packages that you get and whatever features you want. So guys, the coupon code for getting into these packages and getting some discount is SHHPRO, where you get 10% off on the prices. Alright, so let's begin with our classes. And remember, you can join the pro subscription using the link which is there in the description box below. And in case you have forgotten to smash that like button out there, guys, go ahead and yes, smash that like button out there. And if you are a new user to this channel, go hit the subscribe button for free so that you do not miss any of our classes henceforth. Alright, so let's get going. Yep, definitely Vikram. In fact, I will always have 2 morning sessions, you will see, every week. So these morning sessions are useful for all the students who wake up early, plus it makes you motivated throughout the day. And let me just give you a small piece of information. I wake up every day at 5:30 to 6. Yeah, that's my morning wake up time, and I sleep by around 11 o'clock. So I'm an early riser, and it helps me manage my time very efficiently, and it helps me stay fresh and motivated, and also plan my day accordingly, like very well. Yep. So let's get going. Very good. Shreyas Kapri has applied 0.4 Newton. I don't know why. Maybe his mass is 0.04 kg and G is 10. Alright. So let's talk about KVL. Before this, I had shown you how to apply KVL for resistors and batteries. But the new element which has been added out here is the capacitor. So once a capacitor comes, understand things change a little bit, and you just get one extra term when you apply KVL. Now, for those of you who have forgotten or need a quick revision of KVL, well, KVL is nothing but the sum of all the voltage drops across a loop. You take a loop and you sum up all the voltages, that answer is 0. So you start from a point and end at a point, you keep on adding the voltages, whether it is increase or decrease, the sum will be 0 when you return back to the same point. That's what KVL said. Now, we have already seen some rules like, if you have a resistor, okay, and let's say the current is flowing like this. So when you go from this point to this point in the direction of the current, you will see the voltage will drop. Yes, the voltage will drop. We have seen that. And if you go opposite way, obviously it will increase. Similarly, we have seen it for a battery as well. So if you have a battery out here, it doesn't matter, current doesn't matter. So direction of current doesn't matter in case of battery, in case you have forgotten. Yep, it only matters for resistor. Now if you go from minus to plus, you can see lower to high, the voltage will increase. It's obvious, low to high. Remember, only in a resistor the voltage drops. It loses energy when you flow in the direction of current. That's what happens in a resistor. In case of a battery, you go from negative to positive. Obviously, voltage will increase. If you go from positive to negative, voltage will decrease. So this is very important, particularly when you write these equations, because the drops or the gains will have the plus or the minus signs. The last thing out here is for the capacitor. Now, when you have a capacitor, it should be obvious now what you should do. Let's say this has positive charge, this has negative charge. When you go from plus to negative, understand, high voltage to low voltage, positive to negative, field goes from here to there, left to right. Obviously, the voltage should drop. Understand that. And if you go from negative charge to positive charge, voltage will increase. Is this point clear? Let me know in the chat box. Oh, Venkata, I'll tell you what you should do. You should go hit the bell icon, and when you hit the bell icon, there are 3 options: no notifications, or moderate notifications, and all notifications. So make sure you select all notifications out there. Okay, I hope this is fine. Now let's use this in a loop and see what happens. Everybody, let me know if it is clear. Shreyas Kapri, Shreya says clear. Very good, excelente. Now let's use this. Let's take some random loop and see what happens. Okay, let's just take a random loop. Let's say, for example, let's take maybe this one out here. Okay, let's go across this loop and come back over here. So we are going across this loop like this and coming back. So for that particular loop, what are we going to say? First, let's assume the values out here. Without that, there is no point. Let's assume this battery is even. Let's say this resistor, I don't know, I can assume it as R3 or something. I don't know, R1 was there somewhere or R2 is there. Yeah, let's say this is R3. And let's say the charge on this can be written down as, let's say, Q1 or something, or Q2, and this is minus Q1. Okay, and this capacitance, let's say I call it C2. Okay, this is C2 capacitance. It has this much of charge. Guys, do you remember what is the relationship between voltage and capacitance and charge? Q is CV. Yes, Q is CV. So Q is nothing but C2 into V, voltage difference. So the voltage difference here, isn't it Q2 by C2? Do you guys get it? The voltage across the capacitor is nothing but Q2, which is the charge on it. Okay, this was Q2, guys. Yeah, Q2 divided by C2. I hope this is clear. Yep. Now the thing is, once you know this value, this will help us write down the Kirchhoff's voltage law equation. Observe this. Observe. See, let's start with this. Take any point. Let's say I start from here. I go across the first element. What is this? This is a battery. And I'm going from negative to positive, low to high. That means I'm climbing up. So positive. So put plus E1 out here. Okay, so put plus E1. Across this resistor, okay, let's say there is some current out here. Let's say I call it I3. I just assumed it as I3. Okay, I think I3 was already there. So let me use some other value. Let's say I4. Okay, let's say I4. So across this resistor, the current is flowing this way. So the voltage will drop in the direction of current. That's the rule I just mentioned. That's the rule I just mentioned. So what will be the drop? Remember, I into R. That's the drop. I4 R3, but it is a drop, so put a minus sign. I hope that is clear. In the direction of current, voltage drops, so negative sign. And magnitude is current into resistance. V is IR, Ohm's law. Last thing over here, maybe I think there is a capacitor. Okay, across a capacitor, I'm going from plus to minus. So from plus to minus, that's a drop. How much? Q2 by C2. So minus Q2 by C2. That's how you write the equation. Good morning, everyone. Laksh, welcome. Hi, Aditya. Very good, very good. Welcome aboard. And from here to here, look at this. This current is flowing this way. You are coming back here. You are coming against the direction of current. If you are going against the direction of current, voltage will increase. Remember that? I just told you. So plus, this is the current I1 and this is the resistance R1, and you returned back to your original point. So the final sum should be 0. Is everybody clear about this? Shall we do one more? Shall we take one more loop and do this so that everything is clear? Let me know by putting up yo, yes, or clearo, so that we can take up one more loop so that this concept is embedded in your head. Yes, Laksh, sure. Good morning, Shweta. Yes, very good. Let's take up one more loop. Okay, let's take up one more loop. Let's say we take this loop over here. Okay, let's say we take this loop over here. Okay, we have gone like that. So that's my loop. Okay, that's my loop. Okay. Now, let's see whether all the resistors, etc. are mentioned. If it is not, let me just assume the values. Let's say this resistor is R2, this current is I2, this is R1, current is I1, this is C1, this is I3. There is no resistor over here, that's okay. And there is some capacitance, so let's assume some charge. Let's assume this is minus Q1, let's assume this is plus Q1. Okay, just some charge, I don't know. Now remember, Q is CV. So if Q is CV, so Q1 is nothing but C1 into V. So therefore the voltage drop over here is Q1 by C1. Charge by capacitance is the voltage drop across this capacitor. Okay. Now let's apply the KVL law and see what happens. Let's start from here. From here to here, I know you are going opposite to the current, but nothing is present there. There is no battery, there is no resistor, there is no capacitor, there is no inductor, there is no device. If there is no device, why will there be a drop? It's just a plain wire. So from D to C, there is no voltage drop. Everybody understanding this? From D to C, there is no voltage drop. So that's why you start with the term 0. I start from D, go to C, nothing there. From C to B, from this point to this point, I'm going across this resistor R2 in the direction of the assumed current. So remember, in the direction of the current, the voltage drops. So hence negative sign, because it's in the direction of current. And how much will be the drop? I into R. So it will be I2 R2. That's what the current into resistance will be. From B to C, look at that. Current assumed is over here. I'm going opposite to the flow of the current. So it should be an increase. By how much? I into R. That means it will be I1 R1. I hope it is clear. I1 R1. Welcome Trimbak. Yes, I1 R1, that is plus. And the last thing out here, guys, what is this? You're going from negative to positive, low to high, minus to plus. You're climbing. So that's why plus. And how much? This value, which is Q1 by C1. And you came back to this point where you started from, where your journey started from. This answer should be 0. I hope now it's clear how to apply KVL, which also includes capacitors. This also probably brushed your concepts of resistors and batteries as well. Shall we go to some questions? 2 amazing questions for all of you on KVL that will give you an insight of how to exactly apply KVL in capacitor problems. Let me know, guys, in the chat box. Yes, very good. Excelente. Very good. Okay, so I have put up all the rules for all of you. This will be available to you guys in the PDF, which will be put up in the description box below after some time, and also on the Telegram group. So for resistor, for battery, for capacitor, all the rules are mentioned out there. Okay, so let's get going to the next question. In the circuit shown, the question is, what is the charge on the 5 microfarad capacitor? And these are the options given. Very good, Pradyumna. Excelente. These are the options given. But let's not worry about the options. Let me tell you, this is not a straightforward question. Reason, this 2 and this 4 are not in series, because there is some branch coming out here. This 2 and this 5 are not in parallel, because there is some battery in between, nor is this 5 and that 4 in parallel. You cannot convert it into a simple series parallel circuit. So the only option left is to actually, assume the charges and then apply Kirchhoff's voltage law. Okay. Don't worry, Ankit, just take my hint. Yes, Sharp, we will be doing that once, the KVPY date is closer. And by the way, the KVPY batch will start in Vedantu Pro subscription. Okay. Now, let me also tell you one more thing. There will be no current flowing in the circuit. Do you guys agree with this fact? No current. Why? Because the capacitors are charged. Once you have a capacitor which is charged, the charges are developed. That's it. It's saturated. It is done. It's steady. No more charges will flow in or out of the capacitor. If there is no flow of charges, obviously there is no current once it is charged. Remember, I am using the word charge. It's already charged. Only then there is no flow, hence there is no current, because current is the flow of charges. That should be understood. So there is no current here, anywhere. Okay. Now what do? We need to assume some charges. Alright, let's do that. Let's start with that first. Okay, let's assume some charges. Let's assume, okay, this plate towards negative. I'm just assuming this is minus Q1. Okay, just assume this, guys. Is that clear? Okay. Then if this is minus Q1, then assume this as plus Q1 because they are opposite plates, and positive connected here. So let's say plus Q2 and negative, let's say, I don't know, minus Q2. I could be wrong. And if I'm wrong, the answer will come out to be negative of whatever I have assumed. So that's okay. Magnitude wise, things will remain the same. Now for this capacitor, I know what you guys are thinking. Sir, let's assume Q3 and minus Q3. No, don't do that. I'll tell you why you should not do that. observe this. Just observe this. If I draw an imaginary line like this, passing between the plates of the capacitor, tell me one thing, do you see an isolated system out here? It's separate from the rest of the circuit, it's not connected directly. Isn't it isolated system? If it is an isolated system, what happens? Trimbak is just for the love of physics and watching and reading good books and good teachers, that's it. Yes, so guys, think about it. What happens in an isolated system? The charge cannot go out or come in. So before using these batteries, obviously these capacitors would be discharged. Each plate would have 0, 0, 0, 0, 0 charge. Once you charge it, fine, the charges will move around, but the total charge will be conserved. So the total charge will be conserved, and whatever charge was there initially, which is I know 0, will be there finally. The sum of the charges. So think about it. If this is minus Q1, this plate is minus Q2, what charge will be there on this plate? This is minus Q1, this is minus Q2. Let me see how many of you get this. How many of you are able to figure out what's the charge on this plate? Come on guys, the total sum should be 0. If you do not get it, well, it's very simple. Minus Q1 minus Q2 plus I don't know how much should give you 0. So what is that question mark? Obviously that question mark will be Q1 plus Q2. Take both these guys over there. Take both these guys over there. Do you see that? Yeah, very good. So if you saw that, that's it. Just mark that charge over here. This is only via charge conservation I got it. Excellent, Pamu. Oh, no symbol. No, it's not 2Q. Okay, so it is just going to be plus Q1 plus Q2. And obviously on the other side it should be negative of that. So negative of Q1 plus Q2. Okay, cool. That's great. So now let's get rid of this. I don't need this anymore. Now that I know the charges, capacitance is assumed. Alright. So I think I'm free now to apply Kirchhoff's voltage law. Let's apply KVL. Let's apply Kirchhoff's voltage law and see what happens. Okay. So first of all, let's start from this point. Okay. Let's go around this circuit like this. I hope you can see that circuit. Yep, everyone. So good morning, Thanos. Alright, we have, I think, the entire galaxy out here. Both Marvel, DC, I hope. Alright, so we start from 0. We go across the battery, capacitor and come back to 0. So let's do this. Let's go across the left loop. Okay, the left loop. So from here to here, it's plus 6. Well, done. From here to here, positive to negative. So drop, decrease. By how much? Charge by capacitance. I'll put it as 2. Now you will be wondering, sir, it's 2 micro, so you should use micro. Well, let's say Q1 is also in micro. So that's why I don't have to put 10 to the power minus 6. Is that clear? So there is no need of putting into 10 to the power minus 6 because I'm assuming the charges also in microcoulomb. So if you want, I'll mention this. All these charges are in microcoulomb. So that micro will get cancelled. Equations will look much simpler. Go back from here to here. Positive to negative. What is this? Drop. So how much is the drop? It's Q1 plus Q2, which is the charge, divided by the capacitance, which is 5, and that will give you 0. I hope we can see that. Great. Now just take a LCM. You will see what will happen. Yes, the LCM is obviously 10. So 6 into 10, that's going to be nothing but 60 is equal, or rather, I'll put minus sign over here only. So minus 5 Q1 minus 2 Q1 minus 2 Q2 is equal to 0. Therefore, 60 is equal to 5 Q1 plus 2 Q1, that's 7 Q1 when I take it on the other side, and that 2 Q2 stays there as it is. This is equation number 1. Why am I calling it equation 1? Because I have 2 unknowns and only 1 equation. That means I need 1 more equation to solve this question. I just need 1 more. And I think I know what to do. I just need to take the other loop. Yes, just take the other loop. Yeah. So start from here, go like that. Yeah, just start from here, go like this and come back over here. So this is the loop on the right hand side. So start from here, go like that and come back over here. So what am I going to get if I apply KVL? From here to here, negative to positive of the battery, so plus 6, great. There is nothing here. From here to here, I am seeing a jump from positive to negative. That means it's a drop. So there is a drop, so put a minus sign. Magnitude of that drop will be charged by capacitance. Charge is Q2, capacitance is 4. Done, done, done. There is only one part left. So from positive to negative, again a drop. How much is the drop? Look at that. Charge, which is Q1 plus Q2, divided by capacitance. This will be equal to 0. See if everybody understood this equation. Hi Hanuman, welcome, welcome. Let me know guys if you guys have understood this till this point. All we have done is use KVL in the left and the right loop. That's it. Oh, I don't need to mention it as equation 2. Let's just simplify this. That will be better. Yes, the LCM is obviously going to be 20. 4 5s are 20. So 20 into 6, that's going to be 120. So I need to multiply this 5 times. And this will be 4 times. So 4Q1 and 4Q2. That's equal to 0. Shift these guys over there. So you will get 120 is equal to 4Q1 plus 4 plus 5 is 9. So 9Q2. That's equal, that's your second equation. Now you have 2 equations, 2 unknowns. I think now you will be, yes, why we need 2 equations? Look at the question. What is the charge on 5 microfarad capacitor? So you need Q1, you need Q2. You need both the charges. And if you apply KVL, you just get an equation with 2 unknowns. That's why we need 2 equations. Is it clear, Vikram? Hi Nitish, yes. Glad. If everybody has understood till this point, I think we can go ahead. Now you just need to solve these equations. It's very simple. I mean, you can eliminate Q2 guys. You multiply equation 1. Okay, just take equation 1 and let's say, multiply it 9 times and take equation number 2 and let's say multiply it 2 times and subtract them. Just subtract them, you will get the answer. So, because 2 9s are 18, 9 2s are also 18. So 18 Q2 and 18 Q2 will get cancelled and you can solve this and you will get the value of Q1 as well as Q2 from here. Yes, you'll get the value of Q1 and Q2 from here. I think it comes out to be like 60 by 11 and 120 by 11 microcoulombs. And once you know Q1 and Q2, I think you can find the charge on 5 microfarad capacitor. So charge on the 5 microfarad capacitor will be Q1 plus Q2. So it will be 60 by 11 plus 120 by 11, which is 180 by 11. 180 by 11 is how much? At least that much you can do. Nitish, just watch my series, Nurture series for 11th standard on 1D kinematics. I have explained it in absolute simplicity of how to solve problems, and the lecture series are still continued. You will see some more live classes next week. Okay, so 180 by 11 is how much? 18, 10.9, 16.36 or 5.45. Come on my warriors, at least that much you can do. I did so much for you. Come on. Okay, Shreya says C. Okay, very good. Yes, correct. That's the answer. Beautiful. Very good, very good, very good, very good. 16.36. Excellent. Yes, that's the answer. Okay, so what you saw is Kirchhoff's voltage law questions will not come in, just isolation, like a standalone problem. It might be combined with other concepts as well, just like you saw over here. Great. Now let's take another question. Now this is much simpler than the previous one. Trust me on this. In spite of this having more elements, it looks more complicated, but trust me on this, it's not. Okay. 4 capacitors, 2 batteries are connected as shown. VA, VB denote potentials at points A and B. Question is to figure out potential difference between these 2 points. Okay. Ankit, no, if somebody has told you that KVL only comes in current electricity, that is wrong. KVL is a concept which can be used, like Newton's laws. You cannot say Newton's laws will only come in Newton's laws. It will come in RBD also. It will come in circular motion also. You cannot say no, you cannot come here, or you cannot stop kinematics from coming in some other chapter. Same way, KVL is a tool. Understand? Yeah. Okay. So Pradyumna, why don't you post up all your doubts later on in the comment section? I'll answer all of that. Okay. Let's not break the flow of the class. Okay. First of all, here is the trick for solving this question. I'll tell you how you can solve this question in few minutes in the actual examination. See guys, this is a battery. It will make sure that these 2 points have a potential difference of 11 volts. That's the job of the battery. Now this point and this point, this point and this point, do you guys agree have the same potential? And this point and this point also have the same potential because there is a wire. That means the potential difference across these 2 points is also 11 volts. Do you see that? The potential difference across these 2 points is also, 11 volts. Great. That's one thing. Keep that in mind. Same logic used over here. This point and this point have same potential because there is a wire. This point and this point have the same potential because there is a wire. So if there is 14 volts across these 2 points, naturally across these 2 points also there is 14 volts. I hope you can see that. That means the presence of these 2 capacitors did not make much of a difference, because whether this capacitor is there or not there doesn't matter. These 2 points will still have 11 and 14 volts potential difference because there is a battery connected. That battery is important. The capacitor is not. So these 2 capacitors can be completely gotten rid of. Yeah, you can just get rid of these 2 capacitors. You don't need it because the potential difference will still be maintained. It's just a battery which is connected in parallel. So the equivalent circuit, yes, the equivalent circuit of the same thing will look something like this. Well, what you're going to have is that capacitor on the top, that's 3 microfarad. Okay, you are just going to have this battery. Forget the capacitors which are vertical. You're just going to have this battery out here, which is 11 volts, and just one more capacitor here, that's 2 microfarad, and that battery over there, which is like this, and that is 14 volts. That's it, guys. That's the equivalent diagram. Isn't it now simple looking? Now things are a little bit easy. I'll tell you how. Again, if you notice, this is an isolated system. Yes, this is an isolated system. So that means in this isolated system, the total sum of the charge will be 0. And because it is 0, that only says one thing. If this plate has plus Q, obviously this plate will have minus Q. Don't worry, there are not too many charges out here. And if this is plus Q, this is minus Q. And if this is minus Q, this is plus Q. That's it. So plus minus, minus plus, total sum is 0 because it's an isolated system. Great. Now things are very easy. Okay, I don't need all of this now. I don't need all of this. Okay, let's see what we can do. Just apply Kirchhoff's voltage law and you will see you will get the answer. Start from here, go like this. Follow this path. Yes, path for your KVL. Just apply Kirchhoff's voltage law. Trust me on this, you're going to get it. Yep. So all you need to do, you're going from 0 to or low to high across this battery. So plus 14. Okay. From here to here, low to high because negative to positive. So plus Q by C. Q is in micro. 3 is capacitance in micro. That micro goes off. Then go from here to here. That's negative to positive. So that's again, I hope you see that. Yep. I hope you see that. Yes, that's again 11 plus 11. And lastly, minus to plus again increase. So plus, what are you going to get? Q divided by, what is it? 2. That total sum is 0. Just check this out. Just check this out. If this is clear, shall we go ahead? Yep. So 14 and 11, they are going to add. You're going to get 25 out here. And on the other side, okay, you take this on the other side, you're going to get minus q by 3 plus q by 2. Okay, now just take LCM, guys. Just take LCM. So this is going to give you 2q plus 3q, which is 5. So minus 5q, and 3 2s are 6. And there you have 25 out here. You can obviously cancel this out, this 5 and this 5. So you're going to get this. And finally, you're going to get q is equal to minus, check this out, q is equal to minus 30 units microcoulomb. Yep, that's the unit. Now, one thing, remember, yes, why both the capacitors have the same charge? Because it's an isolated system. Look at that. Whatever is there in this boundary is isolated. It's disconnected from the other side. So before using these batteries, both the capacitors would have 0 charges. Once you connect these batteries, they will acquire some charge. I know for sure the sum of the charges should be 0, which is the charge which was present initially. It cannot go out or inside this boundary. That's the whole concept. Yeah. Great. Now, because the q value comes out to be negative, what does it mean? It means the value of charge I have assumed is wrong, sign wise. Magnitude wise, fine, it is 30 microcoulomb. Now, all you need to do is, all you need to do is just show the charges. Okay, so the actual charge over here will be, check this out, this is minus q, right? So minus of minus, that's plus 30, this is minus 30 microcoulomb. Yes, this is plus, this is minus, and over here, this will be minus, this is 30, and this will be plus 30. It's actually flipped. That's the whole concept. Trimberg, by solving lots of problems, that's the only way. Now the last part over here. What does the question actually ask us to do? The question has asked us to find the potential difference between point A and B. Well, that's simple, guys. Start from this point, go here, go like this, and come over here. That's it. Start from point A. So potential at point A is VA. Okay. What do I encounter? I encounter a battery. How much is the increase? 11. So plus 11. That's the voltage increase. So plus 11. I go like this, nothing is there. There is this capacitor. Oh, I'm going from positive to negative. I'm going from positive to negative. So that means drop. How much? Charge. Yes, charge by capacitance. 30 by 2. Okay. And finally, I reach point B. So this, when I keep on adding, subtracting the potentials from point A to this point, finally what I get is potential at point B. I hope this is clear. Yep, this is what I'm going to get. So just subtract that. So VA minus VB will be 30 by 2 is 15 minus 11, and that's nothing but 4 volts. That should be the answer. That should be the answer. So this is how the questions on capacitors are going to be. And you need to become expert in solving these problems. Initially, they might look really hard, time consuming, but guys, obviously, if you want a seat in IIT, if you want a seat in Triple IT, if you want a seat in BITS, if you want a seat in NIT, obviously, there are all intelligent, there are all smart, hardworking people. Understand, more than intelligent, I would say hardworking people, focused people out there. So they do not say, oh, this question is lengthy, I'm not going to do it. Okay, fine, don't do it. Then you can go to a normal private college and then waste your life. But if you want to get into a good college, then obviously you need to work hard, guys. Okay, so don't give up. So that's the answer, 4 volts. Shall we go ahead? Is this common? Well, if a problem from capacitor comes, you might, there is a good chance you might get these kind of questions. Hi, Mumtaz. Yeah. Okay, chalo. Now let's look at plate problems. Now this is much simpler. Okay, let's get to a better question. Okay, so now often you will be given these kind of scenarios where there are some plates and you will be given some distances and you will be asked, oh, what's the equivalent capacitance? And many people face a lot of difficulties here. I'll tell you a simple trick. After this, you will not face the difficulty. The trick is like this. See, whenever you have plate problems, ignore, no, or rather I would say, mark the surfaces. Mark the surfaces of the plates. Always remember, ignore the outermost ignore the outermost surface. You can see there are 1, 2, 3 plates. Each plate has top, bottom, that means 2 surfaces. So 3 plates, top, bottom, will make it 6 surfaces, correct? But the rule says ignore the outer surfaces. So out of 6, 2 surfaces are ignored, only 4 surfaces are there. That means this is surface 1, this one. This one is surface 2. This one is surface 3. This one is surface 4. The outermost are ignored. Keep this in mind. Hi Manoj. Well Ankit, that was from Gauss's law point of view. This is plate problems from capacitor point of view. 2 different things. Okay. Here we are going to find equivalent capacitance. The plate problems what we did in Gauss's law, it's for finding the distribution of the charges. That's completely different. Okay. Let's do this now. Ignore the outermost charges. Done. Now identify your capacitors. Identify the capacitors. What are the different capacitors out here? Guys, the plates which face each other, they form a capacitor. Like I have a capacitor which is C12. First surface, second surface, that's one capacitor. Again, third and fourth, well, I know, that's C34. Now, just draw the equivalent circuit. Just draw the equivalent circuit. Make sure you connect same potential surfaces with wires. So connect all the surfaces with same potential with a wire. Okay, that's all you need to keep in mind. Now this is simple. Okay, let's see what happens. Let's say I take this point as X. Let's say I take this point as Y. From the point X, look at this, from the point X, what do I get? I have 2 capacitors. X potential, the potential at X is same as the potential at 1, is same as the potential at 4. The potential at X, because it's just a wire connecting 2 plates, is same as the potential at first surface and the fourth surface. So how about just connecting a wire and just drawing 2 plates with surface 1 and surface 4. Look at that, X is connected to 4, X is connected to 1. What is opposite to 1? What is opposite to 1? 2. What is opposite to 4? 3. Now what about 2 and 3? Well, 2 and 3 are directly connected to Y. 2 and 3 are directly connected to Y. Don't you see this is nothing but a parallel circuit? This is nothing but a parallel circuit. That's it. So these 2 are actually in parallel. Now therefore the equivalent capacitance between X and Y will be just the addition of the capacitance C12 plus C43, and C12 is epsilon naught A by D, and C43 will also be epsilon naught A by D. So therefore this will be 2 epsilon naught A divided by D. That's the answer. That's all. So just mark the surfaces, identify the capacitors, ignore the outermost, and just draw the equivalent, making sure same potentials are connected by a wire. You can see 1 and 4 connected by wire, 2 and 3 connected by a wire. That's all. Shall we do some questions on this? Simple questions. Okay, great. Come on, buckle up guys, let's do this. Okay, let's do this. So all you need to do, this is how it looks like in 3D guys, by the way. So 3 plates, you can see each plate has 2 surfaces. They are one after the other. The distance between them will be D. Area of the plates will be A. Okay, so I have mentioned all the pointers out here so that it will be there in your notes when you download our PDF from either the description box or the Telegram. So let's see, how do we solve this question? Some more plates are there. Instead of 3, you have 4 plates now. Yes, Manoj, it is. If you know 11th syllabus, only then it is easy. If you do not know 11th syllabus, 12th syllabus is very hard. Compared to 11th, 12th is easy when you know the foundation, the basics. You should know how to visualize, you should know how to think, you should know how to solve problems, you should know how velocity, acceleration works, you should know what is the meaning of fields or forces, how to draw FBDs, what is the meaning of acceleration, what is center of mass. If you know all these things, SHM, waves, things over here look easy. Great. A lot of you are saying B. Okay, let's ignore the outermost surfaces, obviously. So this is surface 1, this is surface 2, this is surface 3, this is surface 4, this is surface 5, this is surface 6. So totally 6 surfaces, ignoring the outermost surfaces. I have 3 capacitors, C12, C34, C56. Okay, these are the 3 capacitors that I get, C12, C34 and C56. Let's start with point A, guys. Let's start with point A and see what do we get. When we start with point A is connected to 1. You can see that via wire, it's connected to 1. Okay, great. So A is connected to 1. A is also connected to 4 and 5. This is interesting. A is also connected to 4 and 5. Okay, let's think about it now. And okay, 4 as well as 5. So A is connected to 4 as well as 5. Okay, let's just draw it as it is. And look at that. Opposite 4 you have 3. Opposite to 4 you have 3. You can see opposite to 4 you have 3. That becomes a capacitor. 3 is connected to 2. Whereas 2 is in front of 1. Acha, in front of 1 you have 2. You can see that in front of 1 you have 2. And 2 and 3 are essentially connected to each other. Yes. And they in turn are connected to this point B. You can see that 2 and 3 connected via this wire to point B. Done. Last thing, opposite to 5 you have 6 and 6 is connected to B. Oh, I think now it looks like a simple circuit. Okay, see guys, what you need to do, mark the surfaces, count the number of plates and mark the surfaces excluding the outermost surface. So this and this exclude. 1, 2, 3, 4, 5, 6. Opposite plates make a capacitor. So C12 is a capacitor, C34 is a capacitor, C56 is a capacitor. That's all. So what I did, from point A, I saw A is connected to 1, A is connected to 4 and A is also connected to 5. They all are at the same potential. Okay, done. Opposite to 1, 2. Opposite to 3 you have 4, or 4 opposite you have 3, and opposite to 5 you have 6. Now you just see that 2, 3 and 6. 2, 3 and 6. All of them are connected to B. 2, 3 and 6 are all connected to B. That's it. How A is connected to 5? You can see that A is connected to 5. This surface is there as a part of this plate. In fact, 4 and 5 are also connected because they are a part of the same plate, same conductor, same potential. A conductor is always equipotential, remember that. Is that clear, Kirti, Suresh? When you have a conductor, all the points are at the same potential, be it 4 or 3, understand, because they are on the same conductor. Yep, so that's why 4 and 5 are at the same potential. That's what many people fail to understand. If this is clear, can we go ahead? Let me know by putting up a yo in the chat box, or putting up clear o in the chat box, so that I know that you guys have understood. Yeah. And let me know if you still want any clarity out here. Yes. All right. Okay, I'll explain one more time, Pranita. See this. Okay, just look at this. For those of you who are probably joining late, I don't know. Look at this. Mark the surfaces. This is surface 1. This is surface 2. Okay. Then look at this. This is surface 3. This is surface 4. This is another capacitor. And lastly, this is surface 5. This is surface 6. Okay. So how many capacitors you got? 3 capacitors. Whose potentials are equal? Let me tell you that. 2, 3 and B and 6. 6, 2, 3, B. All are same potential. 4, 5, 1, A. Same potential. 1 you can see is connected to 4 as well as 5 as well as A. Okay. So start from A, guys. Start from A. Just start from A. From A you get 1. So that's the first plate. Okay. That's the first plate. From A you also get 4 as well as 5. So I mark 4 as well as 5. All these are the different surfaces that I get. Okay. Opposite to 1, what do you have? 2. Opposite to 4, what do you have? 3. Opposite to 5, what do you have? 6. What about 2, 3, 6? 2, 3, 6. All are connected. You can see that. All are connected. Okay. Just one second. 2 and 3 are connected. 5 is connected there. Yep. Everything is connected, and that's connected to point B. Yep. Done. Correct. Is that clear now? Yeah. Is that clear? Yeah. So what are these three in? Come on guys, what are these three things in? Come on, let me know. What are these three things in? Yep. Aren't they in parallel? All in parallel. If all are in parallel, so what is the equivalent capacitance? C plus C plus C, which is epsilon naught A by D 3 times. So where is the answer? This option C. Done. So that's how you need to solve the questions. Let's do one more question so that you get a hang of this. Remember, a lot of people fool you by giving you very simple questions, and then you think that you have studied capacitors. Many coaching institutes don't even discuss this problem. And then you feel that, oh, where did this problem come from? So guys, understand, over here at Enthuse, we try to cover as many kind of problems, as many kind of questions out here. Okay, cool. Let's get going. So there is no point just showing you simple problems and then suddenly the mock test, you see some questions or in the actual exam, and then you will be like, what is this? Okay, let's do one more question over here. Ritik, you will get it, but you would have got the soft copy, bacha. Okay, you would have got the soft copy. I don't know, Ankit. They just want to save time. Or God knows what. You should ask them, not me. I don't do that. Okay, now let's solve this question. What did I tell you first? Mark the surfaces excluding the outermost. Let's start with that. Outermost surfaces excluded. Start from inner surfaces only. This is 1. Okay, this is 2. This is 1 capacitor. Done. Next capacitor. Here. This is 3. This is 4. Okay, this is 3 and this is 4. And then this one. Yeah, this one. This is 5 and this is 6. Okay, cool. Let's start with A and then move around. Let's start with A. Now check first whose potentials are equal. A, 2 and 3. They are all at the same potential. Next up, 4, 5 and B. They are all a part of the same conducting wire or plate. Okay, so they are all at the same potential. Let's start with A first. So we start with A. A is connected to 2 as well as 3. Achha, A is connected to 2 as well as 3. So let's say I draw 3 here and it is also connected to 2. So 3 and 2 are connected. Okay, done. Opposite to 2, you have 1. Opposite to 2, you have 1. I just shown it here. Opposite to 3, you have 4. Yes, you have 4. And guess what? 4 is directly connected to B. Okay, so I'll just say it is directly connected to point B. Done till this point? Next up, what about 1? Check this out. 1 is connected by this wire to 6. So it is connected by a wire to point 6, which is a surface. What is opposite to 6? Well, that's 5. That's 5. And where is 5 connected to? 5 is connected to point B. I think this is like solving a logic puzzle, like those riddles, like a path you have to find in a quiz or something like that. I hope this is clear. Everyone done? Now, isn't it obvious that these two are in series? These two are in series, and when the capacitors are in series, what happens? You have to use 1 by C effective is equal to 1 by C1 plus 1 by C2. So when you use that, the capacitance, if each one of them is C, you will get C by 2. 1 by C plus 1 by C is 2 by C. Flip it, you will get C by 2. Correct. Next up, this one, well, this one has capacitance, let's say C. These two are in parallel. So what is the effective capacitance between A and B? It will be C plus C by 2 because they are in parallel. You can see that. And that's going to be 3C by 2, which is nothing but 3 times epsilon naught A divided by D, and that 2 below. That's the answer. How many of you guys now are a little bit more confident than before for the plate problems? All you need is just more practice at home from H.C. Verma, from Tattva material or previous year books. Come on guys, focus. Yeah, thank you Vikram. Sir, what, how? C is epsilon naught A by D. Any capacitance, remember Ankit? The capacitance is epsilon naught, area of the plate divided by distance. And these two are in parallel, right? This branch and this branch in parallel. So remember, for capacitors, branches in parallel just add. It's not resistors. Yeah, do not forget that. Okay. So Ankit, what we have done, check the surfaces opposite each other. Start from A. Where is A connected? If you are solving more puzzles, you will get this very easily. A is connected to 2 and 3. Look at that. A is connected to 2 and 3. What is opposite 3? 4. What is opposite 3? 4. What is opposite 2? Check that out. 1. Where is 1 connected? Oh, 1 is connected to 6. Check this out. 6. What is opposite 6? 5. Where is 5 connected? B. And where is 4 connected? Well, that's also connected to B. That's it. Now it's a simple series parallel. So this is a trick nobody teaches. You know, they just, in the books, I don't know what they do, yeah. Even books like Cengage and I don't know, so many other books, they just tell ki, acha, this is the equivalent diagram. How did you get to the equivalent diagram? Nobody explains. Cool? Acha, chalo, let's get going guys. Let's get going. Yep. So 3 epsilon naught A by 2D. Beautiful. Now let's come to the next part, that is charging and discharging. Okay. So guys, you are all pumped up or no? Yeah, or lost the confidence? I hope you guys now are more confident to solve these kind of problems, guys. Come on, put up some yo's, some hearts, some yes, some confidence. Show some confidence in the chat box. Yep, put some thumbs up. Very good, Lakshmi. Let's do discharging. Let me just grab my bottle meanwhile. Okay, just a quick feedback. Is this mic sounding better than the previous mic or there's no difference? Very good, Ankit. Thank you, Trimbak. Very good, Vikram is battle ready. Hi, Harshita, welcome. Tarun, yes. Yo. Hello, Yon. Oh, you're from South Korea, I guess. Thank you, Tanushri. Now, I'm going to show you something really cool. Let's see something really cool. Yep. Where we go, there we go. So this is FET, I have already bookmarked it, and this is how I browse through FET, and I want to show you through some nice simulations. Okay, please open up. Okay, great. So there we go, and we select electricity and magnetism, and yep, where is it? Is this the, I guess this is the one. Yep. And yeah, let's play this. Without that chats, without your hearts, without your fire, without your love, trust me, I don't get that energy. That water is useless. That water is just physical. Mental energy comes only from you. Now look at this beautiful circuit. Okay, let's see what is exactly happening out here. I don't need all this. Okay, so you can see on one side there is a battery, there are these wires, there are switches, and there is a bulb. Okay, now right now there is no charge, there is no field, nothing at all. So what we are going to do, we can move the switch here or we can move the switch here. It's up to us. So let's move the switch here. Okay. Now, what we are going to do is take this battery and we are going to increase the EMF of the battery, and let's see what happens. Okay, let's just increase the battery's voltage. Do you see some positive and negative charge came up? And you can see that because this is the positive terminal, you can see that it is developed positive charge. This is the negative terminal, that's why it has developed negative charge out here. Is that clear? I hope everybody is clear. Yep. And if I reverse the voltage, you can see if this is positive, this is negative, this side becomes positive, this side becomes negative. You can also see there is electric field which is developed. If I reduce the voltage, the field reduces, the charge reduces. If I make it 0, then gone, no charge. If I make it like this, positive. You can see more field, more charge. Yeah, I can increase that charge as well. Okay, yeah, there we go. Yes, great, great. Now what I'm going to do is I'm going to put some charge, and let me know in the chat box what's going to happen if I move this switch from here to here. I move the switch from here to here, not here, middle. This switch from here to here. What do you think will happen to the charge? Will it go away or will it stay there? Come on, all my warriors, let me know in the chat box. Yep. So it will not go anywhere, and that's what you will see, because there is nowhere to go. That's it stays there. Yes, it is stored in that. Now if I take this capacitor, put it in my pocket, I can carry this capacitor around and I will have that electrical energy. Yes, there will be electrical field. Yes, the energy will be contained, will be stored inside that field. That field has that energy. That's where it is stored, obviously. And how do I check it? So if I carry this in my pocket somewhere, and now I take that capacitor and connect it to some bulb or motor like this. So I carried it, and see what happens, guys. I'm going to connect it. This is going to be interesting. Look at that. Oops. Yeah. There you go. All the charge went away. Gone. Done. Where did it go? Light, heat. Let's do this once more. Let's charge this. Come on, guys. Let's charge this. Let's charge this, and let's take this back over here. Look at that. The charge vanishes. Entire electrical energy got converted into heat, light, whatever. This is charging. Yeah, this is charging. This is discharging. What will happen if I reverse the battery voltage? Just that the charges will flow in the opposite direction. This will be positive, that will be negative. And now when I do this, anyways, the current will just flow in the opposite direction. That's it. Yeah. Hari Narayan, looks like you get a lot of scoldings from your mom for not turning off the light or the fan. Hai na? Pakka bolo. That's why you are removing all your frustration out here in the chat box. Sir, you forgot to turn off that battery. You must be getting a lot of scoldings from your parents for forgetting. Okay, yes, very nice to watch. So that's what we're going to start with. First, let's start with discharging, and then let's go to charging. It's very similar, you will see that. Okay, so like you can see over here, when you have a capacitor which has some stored energy, you will see that all that energy just goes away in that load, which could be resistance, which could be a bulb, which could be a motor, which could be any electrical appliance. So this decay of current, this decay of the charges is not instantaneous, it is gradual. It does not happen fat say. Oh, no problem. Yawn, no problem. You can use a translator. Yeah, use Google Translator and you can put it over here and probably will understand that, because none of us know Korean. Probably will learn someday, at least a few words. Okay, so yeah, what happens is the current will decay slowly, and I'm interested to find out that function, and that's what we're going to start with. So you have a charged capacitor. These are the three scenarios that I want you to particularly pay attention to. This is a charged capacitor. This is a charged capacitor. It has, let's say, plus Q charge here, minus Q charge here. This is your resistance. At time 0, when that circuit is just complete, when you just turn on the switch, the current at that instant will be 0. Oh, I don't know whether the current will be 0, because the charge will start flowing. So once it starts flowing, there might be some current. I don't know how much is the charge. How much is the current. So let's figure that out, maybe via equations. So you have charge, you have time is equal to 0. Next situation, after some time. So what is this situation? This is basically after some time during discharge. During discharge, what happens is that maybe it has a new charge plus Q, small q and minus q, yeah, small q's. There is current flowing out of it. Let's say I call it I through this resistance, and this current is taking away, it's sucking away all the charge, and eventually after a long time, this is after long time, okay, you will see there is no charge left. It is completely discharged. Yep, it's completely discharged, and there is no current also flowing in the circuit. It's gone, it's done. All the energy is converted into heat or whatever. Okay, now I'm particularly interested in this part. while it is discharging, while the charge is going away, how will the current change? How will the charge change as a function of time? So for that, let's apply Kirchhoff's voltage law. So let's apply Kirchhoff's voltage law for that particular situation. And let's start from this point and go around it. Yeah, start from this point, go around the circuit like this. Let's see what do we get. From here to here, negative to positive, yes, potential increase. So plus, what is the increase? Charge by capacitance. From here to here, in the direction of current, across the resistor the voltage drops. In the direction of current, for the resistor the voltage drops. So minus IR. Rest of the circuit is just plain wires, so nothing over there is equal to 0. Beautiful. Take that IR on the other side. What you're going to get is IR is equal to Q by C. Yep, IR is equal to Q by C. Take that R also here. Okay, you're going to get 1 by RC and you're going to get Q over here. Now this I, current, is rate of flow of charge. Yes, user V, VIT is very overhyped. Very true. That's why I made a lecture, JEE mains versus VIT, and I clearly told you all the things about VIT, but there are a lot more things which I cannot tell you. Trust me on this. I would rather prefer you guys going in another good government college around you out there, yeah, rather than VIT. Okay, so let's go to I. I is nothing but dq by dt, rate of flow of charge. So that is dq by dt, but since it is discharging, charge is reducing, so this derivative will be negative. Like when you are decreasing velocity, acceleration is negative, so rate of flow of charge itself is negative quantity. Okay, now just rearrange this. What you are going to get, minus dq, bring that q below, take this dt there. So you are going to get 1 by RC and dt over here. The reason why I did this is because I can take that minus sign also over here, minus 1. Yeah, the reason why I did this because I want to integrate, guys. Yes, I want to integrate. Let's do the integration. So I'll put integral. Remember, R and C are constants, so I have brought it outside the integral. Again, integral over here. So integrating both sides. Now what should be the limits of integration? The limits of the integration will be the situations, corresponding situations before and afterwards, whatever. You can see when time is 0, the charge on the capacitor is Q. When the time is 0, charge is Q. And when the time is T, the charge is some random Q. That's what I got. Yeah, that's what I got. Now, Jayasuriya, concentrate. You can post up a comment below later on. Let's not disturb the flow of the class. Okay, so integration of dq by k. Guys, 1 by x integration is log of x. I hope you remember this. So this is going to be ln q, but the limits should be put, and that is q and small q, and you have minus 1 by rc. Integral of dt is just t from the limits 0 to t. I don't need this anymore, so I'm just going to get rid of this now. Okay, so what do we get? First substitute q, so ln q, and then substitute ln q, capital Q. So this will be ln capital Q, subtract that, and over here you are going to get minus t minus 0 is t divided by rc. That's what you're going to get, upper limit minus lower limit. Good morning Afaf. And log a minus log b. What is log a minus log b? Log a by b. So this will be log a by b. This will be minus t by rc. Great. I don't need this anymore. I'm just getting rid of this. Now, by definition of log, ln means log to the base e. Understand? ln is nothing but log to the base e. So write it in the power form. You will get q by q is equal to e to the power minus t by rc. Yeah, e to the power, exponential form. So that's what ln stands for, log to the base e. Just rearrange this further. You will get q is equal to capital Q e to the power minus t divided by rc, and that's what I wanted. That's what I wanted. Charge as a function of time. Anish, if I'm going to chill, you are going to chill. If I'm going to rest, you are going to rest. And if you are going to rest, if you are going to chill, you will not clear JEE. If you want to get into IIT, if you want to get a good branch, if you want to get a good NIT, you have to work hard. Because if you do not work hard, there are others who are going to work hard and they are going to get your seat, which could have been yours. Understand? No, Vikram, I am not writing Q to 0 because I want to find any charge at any instant, not final charge. I know the final charge. I want to find charge as a function of time. That's why I put small q. I hope that's clear. Okay, now that we have got this, Vicky, this is more than bolts. This is JEE Mains advanced level. Please understand that. Once we got this, we can also find the current in the circuit. Remember, current is dq by dt magnitude wise. Just worry about the magnitude. So the derivative of this will be q. Derivative of e to the power x is e to the power x only. Derivative of e raised to x is e raised to x. But if there is a multiplying factor, that multiplying factor comes outside. This is via the chain rule. So minus 1 by RC gets multiplied because this is getting multiplied by that variable t. So the modulus of this, the modulus of this, I'm just interested in the magnitude of the current, remember. Therefore, it is equal to q by RC and into e to the power minus t by RC. Q is a constant, R is a constant, C is a constant. Because all of them are constants, I can assume this as I naught. So basically my current is I naught e to the power minus t by RC. Very similar to this formula. Very similar to this formula. What this tells us is that the charge or the current start from some initial charge or initial current. Yes, there is some initial current in the circuit I naught. And as time progresses, the charge and the current both reduce and eventually they die off. Stravana, I will answer all those questions privately, okay, on my Instagram or leave a comment later on. So remember these equations. Now, there is one more thing that I want you guys to remember. See, how will the graph look like? How will the graph look like? See guys, charge is q naught e to the power minus t by RC, isn't it? If you look at the graph of charge versus time, what you're going to see is this. When you substitute t is equal to 0, substitute t is equal to 0, what will you get? Substitute t is equal to 0. E raised to 0 is 1. So you will get q is equal to q. So it will start with, obviously, you'll start with q. Yeah. When you put time as infinity, that's why I put infinity over there. When time as infinity, it will become e raised to minus infinity, which is nothing but 1 by e raised to infinity, which is 1 by a very large number, which is nothing but 0. Yes, it will become 0. So the charge will tend towards 0. That means this charge will decay exponentially like this. This is the curve which it will follow. That's what you can see. It will tend towards 0. It's not exactly 0, but tends very close to 0 because infinity is not a number. It's just some concept. Okay, great. Now, if you have understood till here, one more thing. This number RC is called as tau, which is nothing but time constant. Time constant. This is a special quantity in charging and discharging. Yes, e raised to minus x graph, correct. Now, the thing is, when, all right, time is equal to tau, just think about it. When time is equal to tau, what will this q be equal to? Q will be equal to q or initial charge. Okay, forget this 0. It's not needed. Okay. Just one second. Yeah. Okay. So q is equal to q e to the power. When time is equal to tau, that means denominator and numerator both are same. It will become e raised to minus 1. I hope you saw that. Time is equal to tau when both these numerator and denominator are equal. Now, this is a value which you should remember. 1 by e. because e raised to negative 1 is 1 by e. This value, remember guys, 1 by e is nothing but 0.37. Remember this, let it get inside your head. Just remember this. Yeah, 1 by e is nothing but 0.37. E value is 2.7. Okay, 1 by e is 0.37. Remember that. Okay, now once you get this, the value of q is nothing but 37% of q. This q is 37% of that initial charge. What it means is that when you put time is equal to RC, which is the time constant, the charge which is left is only 37%. It has discharged by 63%. It has discharged by 63%. Yes, and only 37% of the charge is remaining. How many of you guys got it? Did you guys get it? What has just happened? So T is nothing but the or tau is nothing but the time constant, which is R into C, and after one time constant, the charge remaining in a discharging capacitor is just 37%. After 2 time constants, it might be even less. After 3 time constants, it will be even less. After few more time constants, it will be hardly anything. It will be almost like 0. Yes, it will be almost like 0. Yeah, that's how it is. So yeah, I have put up all the derivations and the graph related stuff out here. You can watch that, you can read through it, browse through it later on in the session PDF. Very good. Let's solve a question based on this. Trust me, the questions are not very difficult. Okay, let's see. Find the voltage drop across a capacitor, resistor respectively connected with a resistance and a battery of 100 volts. Okay, come on guys, figure this out. Just draw the circuit. Find the voltage drop across a capacitor and a resistor respectively connected with, a battery. Okay, connected with a battery of certain voltage. How much voltage? 100 volts. Okay, come on. After a long time, very important word, long time. Okay, let's see how many of you get it. Guys, think about it. After a long time, won't it be charged? Didn't I just show you one simulation? You connect a battery, that's it, it will get charged. So it will be charged. And if it is charged, that means there is no more flow of charges. And if there is no more flow of charges, think about it. The current in the circuit will be 0. The current in the flow in the circuit will be 0. And if the current in that circuit is 0, that means clearly one thing, there is no IR. I into R is 0. So the voltage drop across my resistor is 0. Yes, the voltage drop across the resistor is 0. So whatever voltage is there, where will it be dropped? It will be only across the capacitor. So this is 100. This should be also 100. This is 100. This should be also 100. But this is 0. And this is 100. This is 0. This is 100. Naturally, this is 100 volts. So for the capacitor, it's 100. For the resistor, it's 0. That means answer B. Yep. I hope this is clear. Okay. I think now that you have got it, let's get going to the next question. This one is simple. Come on, my warriors, figure this out. It's not that difficult. Come on. Figure this out. After a time of RC, what will be the current if the original current was 2 amperes? Very good, Tanushri. Very good, Srivatsan Ganpati. Excellent. Trimbak, don't worry. It's okay. Happens. Don't worry. Okay, let's go. Yes, Renuka. Next question coming up. What is the current in a... It's not supposed to be charging. It's supposed to be discharging, guys. It's supposed to be discharging. Okay, I'll just edit it in a bit. Okay, don't worry. Yeah, what's the value of the current in a discharging circuit? Come on, figure this out. It's not that difficult. Remember 1 by E value. What is the value of 1 by E? 1 by E was 0.37. If you remember 1 by E is 0.37, trust me, you will get it. It's not that difficult. Okay, what was the equation? I just told you I is equal to I naught e to the power minus t by RC. Yep. Now the question says, if initial current is 2 amperes. Initial current is 2 amperes. And the time is RC. That means this is RC by RC. So this is nothing but e raised to minus 1, which is nothing but 1 by E. Now I just told you what is the value of 1 by E. It is 0.37. 2 into 0.37, what is it going to be? It's going to be 0.74. Yep, very good Vikram, excellent. Viram, I hope you can read the title bacha below. There is a nice title on YouTube. You can see which chapter is going on, everything. Yep, Tanushri, correcto. Yes, very good Venkata. You should solve HC Verma. Guys, I'm telling you all the ranks that I have produced every time. I keep repeating this again because a lot of new students also join in. All my students who have got 2-digit, 3-digit, 4-digit, whatever all India ranks in JEE examination just by using 3-4 simple books. HC Verma, NCERT is for boards, but you use it here as well. Previous year questions by Arihant or Disha publications and Irodov. That's it, nothing more than that. And some problems and assignments and coaching material, whatever you get. Okay, let's do this question. Beautiful question, looks lengthy, but guys, it's not our time to rest now. You guys have to crack it, and trust me, if you guys are not motivated, just do one thing, one simple thing you do. Okay, just do one simple thing. Read through the comments of a lecture which I conducted few days back, VIT versus JEE Mains. You will see the struggle of your seniors. So many students have got so many weird ranks, bad ranks. They are helpless. They want to know what to do next. Guys, I do not want you guys to be there in that situation. Do you guys really want to be in that situation next year? Do you want to struggle? What to do, sir, now? I'm not getting a good college. Should I go to VIT? I really don't want you to do that. If you do not want to be in that situation, you need to work right now. It's not the time to rest. I know some of your friends might be chilling out on a Sunday, posting some vacation pictures. Hey, kya kar raha hai tu? What is this? Come, let's go to a movie. Hey, come on, we are having a party Sunday night, Sunday evening, Sunday, and we are having barbecue and all. Don't listen to them. They might be doing barbecue party now, but you will be partying later on next year with all your new friends in IIT. You want to do that, guys. Understand? You want to do that, not party right now. You have to sit and study, and we are doing a lot of hard work for you guys. So yes, please reciprocate that way. Let's get going to this question. Okay. Let's see be the capacitance of capacitor discharging. Okay, T1 is the time taken for the energy stored to become half. Acha, so it's a question on energy. Energy becomes half and 1/4 in two different scenarios. The value of energy is Q square by 2C. Q is initial charge into e to the power minus T by RC and whole square, the whole thing divided by 2C. That's the formula for discharging of a capacitor. Now when I square it, what I'm going to get is Q square by 2C into E raised to M raised to M. A raised to M raised to M or N is basically A raised to Mn, product. Understand, the product of the powers. That's the rule of exponents you would have studied back in lower grades. So this will be E raised to minus 2T by RC. Okay, that 2 and this number gets multiplied. Now what is this number? Well, I know what is this. This is the original energy stored. So this is nothing but U0 into e to the power minus 2T by RC, and U by U0 will be nothing but, I'll just put it as 1 by, so that it's clear. So 2T by RC. Yes, this is what it is. I will use this now again and again. I think I'm going to need this. Okay, I'll just keep it beside. Now let's take the first situation. What is the first situation? First situation, it becomes half of its initial value. That means this energy has become half of the original energy. So this ratio is nothing but half. Okay. In how much time? In how much time? T1 time. Yes, it has taken T1 time to become half its value. So I'll just put 1 divided by e to the power 2T1 by RC. Flip it. So you will get 2 is equal to e to the power 2t1 by RC. Bring it to logarithmic form. So it will become ln, because this is e raised to something. So ln2 is nothing but 2t1 divided by RC. This is one equation. I'll get one more equation, guys. How? Look at the second situation. It takes time t2 for the charge to reduce to 1/4 of its value. 1/4, sorry, not charge, my bad. I think this should not be charge, this should have been energy, guys. My bad. This should have been energy. Okay, this is not the word charge, this is energy. I'll just edit it in a bit. Okay. And now think about it. If the energy becomes 1/4, this ratio will become 1/4. This ratio will become 1/4, and I will have 1 by e to the power 2, but that's a different time, t2, okay, divided by RC. Now flip it, you'll get 4 is equal to e to the power 2t2 by RC. Bring it into logarithmic form just like we did here. So it will become ln4 is equal to 2t2 by RC. Now you guys know what to do. The last step, what you need to do, guys, take this and take this, divide both of them. Yes, just divide both of them. Just divide both of them. Just divide both of them. Yep. So you will get ln4 by ln2. ln4 by ln2 will be nothing but t2 by t1, because everything else will get cancelled. What is ln4? 2 ln2. So it will become 2 ln2 by ln2 is equal to t2 by t1. So therefore t2 by t1 is 2 by 1. The question is t1 by t2. So hence the answer will be B. So that's the answer, guys. Beautiful, beautiful, beautiful. Let's take up one more question, guys. Yep, let's take up one more question. Now, the only way for you guys to get confidence is when you solve more problems, and that's why I'm conducting this big class. So more half an hour, guys. Stay tight. Do not look anywhere around. Do not get distracted. Stay with us. Okay, stay with me so that you become expert. After that, you will not cry again. Okay, let's do this question. Capacitance is given, energy stored is given, resistance is also given. Okay, so everything is given. The question is basically, what is the initial charge, what is the current initially, and what is the initial rate of loss of energy? Well, that's simple. First, visualize what is happening. There is a capacitor, there is a resistor, and when you just turn on the switch at t is equal to 0, okay, when you close the switch, it will start to discharge. So this is beginning to discharge. That's a question on discharging of the capacitor. Let's start solving the problem. It's not that difficult, trust me. What is the initial charge on the capacitor? Well, I know the energy, I know the capacitance. U is original charge, Q square by 2C. Just use this formula. Everybody knows this formula. Energy is, Q square by 2C. What is the energy? 0.5. What is the charge? I don't know. What is C? Well, C is 1 microfarad, so 10 to the power minus 6. Okay, and just bring it there. Yep, 2 into 0.5 is 1. So 10 to the power minus 6 is Q square. Yep, so therefore Q will be root of this. So it will become 10 to the power minus 3 coulomb, which is 1 millicoulomb. So we have got one answer over here. So first is done. Okay, great, simple. Very good. Let's go to the next part. What is the current through the resistor when the discharging starts? Oh, that means the question is, at t is equal to 0, what is the current? I hope you remember that equation which I gave you. Current is initial current, which was Q by RC into e to the power minus t by RC. This was the value of current. This was your initial current, if you remember the derivation. Yes, this was the derivation, and in that I told you Q by RC is the original current. It also decays exponentially. So I naught will be Q from here, which is 10 to the power minus 3, divided by R into C. What is R? R is 1 mega ohm, that is 10 to the power 6. Capacitance is micro, which is 10 to the power minus 6. 10 to the power 6, 10 to the power minus 6 goes away. So it is just 10 to the power minus 3 ampere, which is again 1 milliampere. So that's the initial current. That's the initial current. Clear? Very simple? Great. Last step. So this is also done. Okay, let's go to the last part, C part. Initial rate of loss of energy. Rate of loss of energy is nothing but the power loss in that resistor. Because I just showed you some time back a simulation. The energy stored in a capacitor completely gets dissipated in the form of heat, light, whatever, in that resistance or that load. What is the heat loss formula for a resistor? It's nothing but I squared R. I just figured it out. 10 to the power minus 3 whole square into resistance 1 mega ohm. That's 10 to the power 6. Obviously 10 to the power minus 3 whole square is 10 to the power minus 6. 10 to the power minus 6, 10 to the power 6. Okay, it's just 1. So 1 watt. That is the answer. That's the power. The answer. Very good. Excellent. So guys, tell me one thing. Did you guys get now some confidence in solving capacitors ka charging and discharging? Now we are going to charging wale questions. Don't worry. Now these were all questions on discharging. Now let's go to charging wale problems. Yeah, these were the answers. And remember guys, if you have any doubts, alright, you can always message us on our doubt app. And even during our classes in Vedantu, you can ask doubts. This is how the wave platform on Vedantu looks like. This is the chat box. This is where the teacher is there. You have all interactive slides, simulations and all that. And these classes also come with quizzes. These statistics are stored so that you can look at them as a report card, and it will act like a self-reflecting activity for all of you, so that you yourself can analyze where you guys are going wrong. Acha, these are the number of quizzes I answered. Leaderboards are there, which are very fun. So you guys can participate in quizzes every now and then, and it keeps the entire competitive spirit of that class alive. And that's why Vedantu classes are very much different than what you see on YouTube. Okay, so excellent, very good, Giri, very good, very good. No, Venkata, I think you made a mistake out there. Yep. Okay, just check this out. Okay, great. Let's go to charging. Okay, let's get to charging of capacitors. So the same procedure follows. So when you have a battery connected to a capacitor, the charge slowly builds up. So you will see this is just the start. At the start, you will see there is no charge. After some time while charging, you will see that the charge will be Q. Here it will be minus Q. There will be current flowing in the circuit, and this will be fully charged. This will be fully charged after long time. And let's say that charge is plus capital Q minus capital Q. And once it is fully charged, the current in that circuit will become 0. Yep, makes sense, because once it is charged, why will current flow, right? It's charged, no more need of current. So the formula for this one is slightly similar but also different. You will see this. So it is nothing but CE 1 minus e to the power minus t by RC. That's the only difference. So you have 1 minus something, not just e raised to something. 1 minus e raised to minus t by RC. So that's the value of charge. And if you differentiate this, if you take the derivative of this, you will get the current, and that value, yes, that value comes out to be E by R, magnitude, I'm just interested in the magnitude, E by R, e to the power minus t by RC. This is also a formula which you should remember. Yep, this is something which you should remember. The last thing that I would like to tell you guys over here is the graph. So how will the graph look like? Well, see guys, it's simple. Q is CE 1 minus e to the power minus t by RC. Okay, this is the formula. Okay. Now if you put t as 0, okay, this will become e raised to 0. E raised to 0 is 1, and 1 minus 1 is 0. So Q will come out to be 0. That means the graph will start from this point. So which graph I am trying to draw? Charge versus time. Similarly, when you put the time value as infinity, time is infinity, it will become e raised to minus infinity, which is same as 1 by e raised to infinity, which is 1 by a very large number, which is nothing but 0. So it will become 1 minus 0. So you will get the charge is equal to C. This is your final charge, capital Q. Yes, this is your final charge. So what happens is, this graph looks something like this. And it will exponentially increase. And finally, it will become capital Q, which is CE. That's the final charge. Yeah, this is the final answer, guys. Yeah, this is how the graph looks like. It builds up slowly. It starts from 0, and you can see eventually it builds up to capital Q. Eventually, it builds up to capital Q. Everybody clear about this? Shall we go ahead? Yeah. Now, one more thing that I want you guys to see over here is what happens when T is equal to tau, which is nothing but RC, the time constant. Yes, the time constant. Then you will see this expression will become CE 1 minus e to the power. T is equal to RC, right? RC gets cancelled, e raised to minus 1. This will become CE 1 minus 1 by e. CE is nothing but final charge. And 1 by e, I just told you, is 0.37 previously. Remember this value, 1 by is 0.37, standard value. 1 minus 0.37, that's 0.63. So 0.63 times of Q. 0.63 times of Q. Yes, you should, Srivatsan. So what does this tell you guys? When the time is tau, then it is 63% charged. Yes, it is 63% charged. When the time constant is achieved, you get 63% charge on the capacitor. 2 time constants, even more charge. 3 time constants, even more charge. So after every time constant, you will see the charge percentage on that capacitor increases. Let's solve few questions and then let's get going. Yep, let's get going. Okay, chalo. Remember this. All this data has been presented here so that in case you need the derivation, the formulas, it's available in the PDF. Let's see how many of you warriors are going to do this question. If you have resistor, capacitor, battery, what is the initial current? I just told you that formula. It was E by R, e to the power minus, or rather the current is E by R, okay, e to the power minus T by RC. Remember, this is initial current. This is your initial current. So just do E by R. So just do E by R. 400 divided by resistance 20. 400 by 20, guys. How much is it? Yeah, got it? Got it or no? Finally, yeah, that's the answer. Correct. 20 amperes. I hope you guys got it. Yes. The dates, BTS, nobody can tell, but I'm expecting July end or August. July end now seems more unlikely, BTS, but most likely August only. Yes, it is a marathon. I told you guys, it's because we had discontinued the class. We had to stop midway because my mic had some issue, remember? So that's why all those lectures are piled up and I wanted to do it once and for all. So next time we can do advanced questions and then we can also go to Menti quizzes and all that stuff. Yep. Okay, let's see this question. In a RC circuit, voltage, resistance, capacitance, everything is given. Okay, the question is to figure out what is the maximum charge, time constant, how long does it take to build the half of the final charge. All these are the questions. Let's do this one by one. First, let's take care of the time constant. First part, time constant. I just told you time constant is RC. What is the value of R? 1.4 mega. Mega is 10 to the power 6. What is C? C is 1.8 micro. So 1.8 micro, that is 10 to the power minus 6. 10 to the power 6 and 10 to the power minus 6 goes away. 14 into 18, 252. So it will become 2.52 seconds. That's the value of time constant. So first answer is done. It's simple. You just need to use formulas. Okay, let's go to the second part, B part. Find the maximum charge that will be appearing on the capacitor. Now Q max is nothing but capital Q, which is nothing but C. The final charge, remember that graph I told you. The final charge eventually after a long time is nothing but C. So what is C? Well, C is 1.8 micro, which is 10 to the power minus 6. What is E? That's 12, guys. So what is the final charge going to be? Come on, 18 into 12. Yes, 216. So it will be nothing but, yeah, 21.6 you can put. Yep, 21.6 microcoulomb, because 10 to the power minus 6, right? So 21.6 microcoulomb. Yeah, that's the answer. Beautiful, Vikram. Beautiful, Reaper. Excellent. Last part of the problem. Last part of the problem. How long does it take for the charge to build up to half its final charge? Q is equal to Q e to the power minus t by RC. Half its final charge. That means Q by 2. This is the final charge. E to the power minus t by RC. Q goes. Q goes. So it will become half is equal to e to the power minus something is 1 by something. So e to the power t by RC. Great. Now what do I do? Flip it. So 2 is equal to e to the power t by RC. Now what do I do? Guys, it's an exponent form. Use logarithms. So it will become ln2 is equal to t by RC. Yes, just use logarithms. You will get it in this form. Last step. T is equal to RC into ln2. I think I know the value of RC. Look at that. RC's value I already knew. It is 2.52. Last step. Log of 2. What is log of 2? 0.693. Yes, 0.693. So if you just calculate the approximate value, just check it out. How much do you get? How much do you get? I think you will get it close to 1.75 seconds. That's the final answer. So it takes 1.75 seconds to build up half the final charge. This problem clearly tells you how quickly a capacitor charges. I have taken more or less realistic values of capacitances, EMF, etc. Within 1.75 seconds, it's half charged. Within 2.52 seconds, it is 63% charged. And you can see the final charge stored in it is just 21.6 microcoulombs out there. Excellent. Yeah. So that's the answer. Okay. Now, this is something very simple. I would say that you will be able to solve it within 20 seconds. What happens to a capacitor when the capacitor voltage is equal to the source voltage? Yes, when the capacitor's voltage drop is equal to the source voltage drop, guys, what will happen? Come on. It's very simple. It is charged. So if it is charged, what will happen? There is no more further flow of charges. That's it. It's off. It's saturated. It's steady. It has achieved steady state. No more current. The capacitor has turned off. That's what it's called. Yes. Not Q is not zero. Q is there. Q is final Q. Capacitor has switched off. That means it has started blocking the current because there is no further flow of charges. Understand that. That's the meaning of switching off a capacitor. Okay. Now the last trick I want to give today, and then we'll call it off. Yeah, we'll call off this session. Last trick, which will be very useful. The trick is this. Guys, just get back to that charging equation. So remember, while charging, I just told you it is E by R. Okay, E by R, e to the power minus t by RC. This was your initial current. This was your initial current. This was for charging. Now, the interesting part is that when t is equal to 0, I just told I is equal to E by R. This means when you have a capacitor, resistor connected across a battery, EMF E, the initial current is just E by R, as if this capacitor is not there and there is a wire. I'll just repeat. I'll just repeat. Yes, no movement of charges, Giri, correct. Initially, when the current is E by R, it's as if, this capacitor is not there and there is a wire out there. As simple as that. That means, whenever a capacitor is just connected to the battery, you can always, assume it as a wire. You can just always assume it. What can you do? When a capacitor is just connected to the battery, always you can convert that capacitor into a wire when it is just connected. Keep this in mind. Everybody clear about this? Lakshmi, that was for charge. For Q, it is Q1 minus e to the power minus t by RC. When you differentiate it, I will come out to be I naught e to the power minus t by RC. One term will go off. Derivative of constant is 0. Okay, I hope you guys get it. Rahana Rinu, where is Wasim sir? Wasim sir will come probably whenever his lecture is there. Right now my lecture is going on, so that's why I am here. Okay, don't worry, Wasim sir will be there for chemistry class. Now this is a physics class. Last thing, if a capacitor is already charged, what will be the current in it? It will be 0, right? There will be no current in it. And if there is no current in it, isn't it like an open switch? Isn't it just like an open switch out there? Think about it. So guys, this is the trick. When you just connect a capacitor to a battery, it is like a wire or a closed switch. When the capacitor is completely charged, done, circuit is broken, it is like an open switch. That's the trick, and that's what I have written over here. So when a capacitor is completely charged, it's like an open switch. That's the equivalent diagram. When a capacitor is just connected across a battery, then it acts like a closed switch. This is what you should keep in mind. Okay, let's solve a question based on this. Here it comes. Yep. Look at this very simple question. Let's see how many of you can get this. Come on, my warriors. There is a battery, there is a switch, there is a resistor, there is a capacitor. At t is equal to 0, that means you just connected. When you just connect a capacitor, what will that capacitor behave like? The capacitor will behave like a wire. It will behave like a wire. So you just have that resistor, you just have that battery, nothing else. So what's the current, guys? EMF, what's the EMF? 20. What's the resistance? Where is it? Of resistance 10, this should have been ohms. Yes, this is 10 ohms. So 10, that's nothing but 2 amperes. Yep, 2 amperes. Isn't it simple, guys? Yeah, that's the current. And at infinity, that means it is fully charged. When it is fully charged, what will happen? It will completely block that current. So even if you have that battery and this resistor, this part is open. So the current in the circuit will be 0. It's blocked. It's cut off. It's turned off. It's going to cut off that circuit. It's like an open circuit. So hence, the answer will be 2 amperes and 0 amperes. Yep, 2 amperes and 0 amperes. Yes, option D. Beautiful, Tanushri. Excellent. Beautiful. Guys, one last question. And if you guys are able to do this, trust me, you have understood this. Yeah, last question for today. Okay. There is a switch here. I'm just going to close it. And the question is, what's the current in the battery when I just close it and after a long time? So two situations are given. Okay, so there are two situations out here. What is the current in the circuit when it is just being closed? That means t is equal to 0. And after reaching steady state, that means t is infinity. Two situations. When it is just closed, what did I just tell you? This capacitor behaves like a, what does it behave like? A wire. That's it. Like a closed switch. So just do that and redraw the circuit. It is simple. Just think this is a wire and just look at this problem. This is a resistor. This is another resistor. Well done. This is another resistor and there is a battery over here. That's it. This is the circuit. Now these two, 20 and 20 together will make how many ohms? 10 ohms. They are in parallel, right? 20 and 20 will make it 10 ohms because they are in parallel. And this is 5 ohms in series. Yep, 5 ohm in series. So what's the current? What's the current? EMF, what's the EMF? 10 by resistance 10 plus 5. Isn't that clear, guys? Everybody getting it? Yep. Everybody getting it? Yep. Very good, very good, very good. So what's the answer? 10 by 15, which is nothing but 2 by 3. Yes, 2 by 3. Yeah. Beautiful, beautiful, beautiful. Excellent, excellent. So 2 by 3, well, I think 2 by 3 is 0.67 amperes. So I think it should be one of them. Now, which one of this is correct? For that, use this part. Time is infinity. The capacitor will behave. The capacitor will behave like an open switch. It's blocking this part. That's it. Nothing will go here. So only think of this resistance, and this battery. Nothing else. Nothing else. This battery, this resistance and this resistance, nothing will go there. So what will be the current there? What will be the current there? Voltage. Voltage is 10 divided by resistance 5 plus 20, which is 10 by 25, which is divided by 5, so 2 by 5. 2 by 5 is 0.4 amperes. So option C is correct. Now you should have tremendous confidence in capacitors, guys. Yeah, and I have placed some 2-3 homework questions. If you are able to solve these homework questions, trust me, you are going to master, you are going to nail it, you are going to kill JEE Mains examination and JEE Advanced examination. This is your second question. Okay, so you need to solve this and post the answers in the comment section. I'll be seeing who will be answering really quick. And the plate problem, don't get scared. It's simple. Trust me on that. Use my method. So find the equivalent capacitance. And remember, if you want to study under me, if you want to get into the topper batch, I'm teaching right now in the topper batch of the 12th standard. And if you do well, you can actually get into the topper batch. All you need to do is be consistent, be regular in your studies. And remember, even in the normal batches, everyone is amazing. People are doing really well. You get assignments, you get Tattva module, you get what not. I mean, you get doubt solving, you have tests every alternate Sunday or something. And not just that, guys. I mean, you get so many assignments, PDF notes, replays that you will never feel that there is a dull moment in your life because you have so many things to solve. So all of this is there in the pro subscription. And remember, if you want the doubt solving, you go with the classic version. If you want a personal mentor, you go with the plus version. Like you can see, these rates are really affordable. And you can use my coupon code SHHPRO and you will get 10% off. And using this, if any problem happens, so I can get in touch with the team at the back end and get your, problems resolved as well. So that's why you should use my coupon code out there. Well, Chaitanya, I'm not sure, but let's see how things go. Sarin, I'm an English teacher and I'm guessing I'm teaching as good as possible as the Hindi teacher. So that's a wrong notion that many students have, that, oh, English teacher means no, he will not teach good. No, that's not true. Okay, great. So guys, I hope to see you in the next class, and I will start with the magnetism also next week. What's my name? My name is Shreyas. Okay, chalo guys. I hope if you have enjoyed the video, please do not forget to smash that like button out there. Please do that, show some love, and hit the subscribe button so that you do not miss my next class. This was Shreyas here, your physics master teacher. Hasta la vista, guys. Take care.